Hello everyone, this is the start of our Ready New York lessons. You were told to start at lesson 4A and then you will end up continuing on through the rest of the unit. Now lesson 4A is explaining relationships in scientific and technical texts. So our learning target is to be able to explain the relationships or interactions between events and ideas, and it will help you develop a deeper understanding of scientific or technical texts. Now scientific just means it's going to relate to science. Technical texts usually are something that's telling you how to do something. So it says when you read scientific texts, you learn about the natural world. If you read about why lightning strikes or how electricity works, you are reading a scientific text. When you read technical texts, you are learning to make or do something. If you read the directions for using a cell phone, you are reading a technical text. Both scientific and technical texts describe the relationships and interactions between events, ideas, or concepts. Now, the little paragraph they give us at the bottom, they're going to have us read this passage, and then we're going to underline any relationships or details that seem important. So whatever we think might be important to something further on. So this is called electricity and motion. You're pretty familiar with what electricity can do. You flip a switch and a light bulb glows. You push a button and a fan whirs to life. Turning on an electric oven makes it heat up. But why do you get these results? What do a glowing light bulb, a spinning fan, and a hot oven have in common? The answer is current electricity, or the steady flow of bits of matter called electrons. You can't see electrons. They're so small that even the best microscopes won't show one to you. But while electrons aren't visible, you can see the effects of their motion. Light bulbs, fans, ovens, all of these work because you let the electrons flow. So we're going to underline some things that I think are important. So we'll take it line by line. You're pretty familiar with that doesn't really give us any information, so it's not that important. But the end of the sentence says what electricity can do, because this is electricity in motion, so it's telling us what electricity is able to do. We might also underline the examples. You flip a switch and a light bulb glows. You push a button and the fan comes to life. Now, the rest of the paragraph there is just kind of asking us questions. It's not really giving us any important information. The next paragraph says the answer is current electricity. Okay? Well, current electricity is important. Now remember, when we underline important details, we don't always need to underline the entire sentence. So we're just going to underline current electricity. And that is the steady flow of bits of matter called electrons. And the last important thing we're going to kind of underline is that all of these work because you've let the electrons flow. Because if you didn't turn stuff on, it wouldn't work. Okay, those electrons would not be flowing. So we're going to kind of take that information here and help us to fill in these boxes. So it says, consider what you know about scientific and technical texts. What process does the passage describe? How does one event lead to another? So it's kind of like sequence. So they filled in event number 1. You flip a light switch. So what has to happen when you flip a light switch? Well, if I'm looking at my text here, it says that I flip a switch and a light bulb glows. Well, is that all it has to do? I flip the switch and the light bulb just automatically glows? No, we need something kind of in the middle. They give us that answer further on. They tell us that the answer is current electricity, that the electrons are moving. Okay, if these electrons didn't move, then the light would not go on. So event number 2 is just going to be that the electrons start moving. And then we kind of talked about it. So we flip the switch, the electrons are going to start moving, and then what's going to happen? A light bulb comes on. Okay? So I'm going to give you a minute to do the explanation of the process, and then I'm going to move on to the next thing. So all you basically have to do is take these 3 events and put them in a complete sentence. Okay, so on the last page, you should have filled in the explanation of the process by saying something like you flip the switch and then that starts the electrons moving, and then when the electrons are moving, the light bulb is then going to turn on. So basically, it has given us light to see. Now, our next story is electricity and batteries. And then we're going to fill in the same type of chart on the next page, event 1, 2, and 3. Okay, so it says, electricity powers our smartphones, music players, and other devices. Where does the electricity for these small machines come from? Batteries, of course, but who invented the battery? And what did a battery teach us about the relationship between electricity and magnetism? Let's begin with the invention of the battery. In 1799, scientists didn't know much about electricity. When faced with the unknown, scientists get curious. And Alessandro Volta was curious indeed. Volta discovered that he could produce electricity by dipping 2 different metals, such as zinc and copper, into a glass of salt water. He experimented further. First, he soaked small pieces of cardboard in salt water. Next, he sandwiched 1 piece of soaked cardboard between a copper disc and a zinc disc. Finally, he stacked several such sandwiches into a pile. When Volta attached a wire to the top and bottom of the pile, electricity flowed through the wire. The first battery was born. In the following years, scientists made discoveries about electricity. One of the most startling of these came in 1820. In that year, the scientist, Hans Ørsted, observed that a compass needle will move when brought near a wire hooked to a battery. Ørsted, knowing that compass needles respond to magnets, realized that electric currents produced magnetic fields. Ørsted's recognition that electricity and magnetism are related was one of the most important discoveries of the 19th century science. Today, batteries and magnetism are so common that you probably don't give them a second thought. But to people of 1799 and 1820, Volta's and Ørsted's discoveries were magical. If you ever get the chance to build a battery and use it to generate a magnetic field, you might experience a bit of old magic for yourself. Okay, so our close reader habits. It says, as you reread the science text. Now, I'm not going to reread it to you, but if you want to, you can reread it again yourself. Circle the words that show the steps Volta followed. Okay, so we want our signal words here. So we need to go back up to our second paragraph. It's labeled with a 2. And we're going to discover his steps. Now, we're going to look for words such as first. Okay, then it says, first, he soaked it. Next, he sandwiched 1 piece and soaked the cardboard. Then finally, he stacked several of them in a pile. Okay, so those are all his steps right there. First, next, finally. Then underline the sentence that tells you the results. So what happened? So he stacked them up. When he attached the wire to the top and bottom of the pile, the electricity flowed through the wire, and the result is the first battery was born. Now, our little organizer on the other side, so it looks just like the other one we completed, event 1, 2, and 3. Event 1, Volta put small pieces of cardboard between the discs of copper and zinc and stacked several of them together. Well, when we looked back, what was the thing that he did after that? So first he soaked it. Next, he sandwiched them, is what they just said. Okay, he put the pieces of cardboard together. So we're going to look at these last kind of details. So when he attached the wire to the top and bottom, electricity then flowed because they combined a few of our steps in event 1. So we're going to say electricity flowed through a wire attached to the top and bottom of the stack, making a battery. Now, I know some of you struggle with taking notes in class as I do it. With a video, for the sake of time, I cannot sit on the same screen, but you all have the same capability to pause the video and fill in the box completely. Okay? Event 3, so what was kind of discovered from all of this, because it wants the events in paragraphs 2 and 3. We're going to talk about the third event was Ørsted. Okay, I know it's not spelled the way it's pronounced, but in our little reading in the parentheses, that's what it means when it gives the pronunciation. So Ørsted discovered that a compass needle moves if it is near a wire connected to a battery. Okay, and that fills in our chart. Now with these videos, I'm going to try and keep them to 2 different parts because as you guys know, we do have the short response that we also need to do. Those will be a separate video. Okay, so make sure you're paying attention to the titles of the videos, and then we will meet back together to do the short response.